Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at an introduction to integration. Now, integration is the inverse function of differentiation. And when we were looking at differentiation, we learned that if you're differentiating a function of the form ax to the n, you get nax to the n minus 1. In other words, when you differentiate ax to the n, you multiply by the power, and the power goes down by 1. When we integrate ax to the n, we do the complete opposite. In other words, the power goes up by 1 and we divide by the new power. For example, let's say I had to integrate y equals 8x cubed plus 3x squared plus 5x plus 4. I'll let you have a go at doing that yourself first, so pause the video, have a go and come back to me when you're ready. Okay, a couple of things first of all. One just to do with notation. When we're differentiating something, we write dy by dx. When we're integrating something, that's the symbol that we use, like a long stretched out S. That means the integral of this function with respect to x. And the other thing to notice, I've chosen to write 5x as 5x to the power of 1, and I've chosen to write 4 as 4x to the power of 0. X to the power of 0 is 1, so that'll just give me 4 times 1 is 4. But writing it like that just makes it easier to use the rule. Okay, taking it one term at a time. If I integrate the first term, the power will go up by 1 to x to the 4, and I'll have to divide by 4. For the second term, the power will go up to x cubed, and I'll divide by 3. The power will go up to x squared, and I'll divide by 2. And here, the power goes up to x to the power of 1, and I have to divide by 1, which gives me 4x over 1. And that would simplify to 2x to the 4 plus x cubed plus 5 over 2x squared plus 4x. Now, there is a particular issue with integration, which is related to what happens when you differentiate a constant. For example, if you had y equals 3x squared plus 5x, if I differentiate that, I get 6x plus 5. But equally, if I had 3x squared plus 5x plus 8, when I differentiate it, I get the same thing, because the differential of 8 is 0. Or if I changed it to 10, the differential of 10 is 0. It doesn't matter what the number is. If I've got any number added on, when I differentiate it, the number will vanish. In other words, when we differentiate a function, we lose any knowledge of what constant might have been part of that function. Or in other words, if y equals 3x squared plus 5x plus c, any constant, when I differentiate it, I'll just get 6x plus 5. Now, if I write this backwards, and instead of differentiating, I integrate the answer, then the integral of 6x plus 5 will equal 3x squared plus 5x plus some constant that I don't know. It is possible to work out that constant if you're given extra information, but if you're not given any information, you do just have to leave it as plus c, plus some arbitrary constant. So in general, when we integrate a function, any function at all, you'll get the integral of whatever that function is, plus some constant. And if the function is ax to the n, then when I integrate ax to the n, I'll get ax to the n plus 1 divided by n plus 1 plus a constant. And that's just the formal way of writing down the rule we were using just now. The power has gone up by 1 and we've divided by the new power. Okay, example 2. Bearing that in mind, have a go at integrating y equals 15x squared with respect to x. Pause the video, come back to me when you're ready. Well, the integral of 15x squared, you add on 1 to the x squared to make it x cubed, you divide by the new power, and now we know you also need to add on some arbitrary constant c. And that'll give us 5x cubed plus c. Okay, example 3, slightly longer, but the same idea. Have a go at that, pause the video, come back to me when you're ready. Okay. I've rewritten it. You don't need to do that, but I've rewritten it just to make it absolutely clear what's going on. And then integrating it one term at a time, x cubed goes up to x to the 4 and I divide by 4. X squared goes up to x cubed and I divide by 3. X to the 1 goes up to x squared and I divide by 2. And then 8x to the 0, power goes up to 1 and we divide by 1. And we need to remember the arbitrary constant. And tidying that up would give us that. Okay, example 4, same idea, except you have to do a little bit of work at the beginning. So we can integrate terms of this form, some number times by x to some power. If the terms aren't written in that form, we need to change them so that they are written in that form. I'll let you have a go at doing all of that. Pause the video, come back to me when you're ready. Okay, let's have a look at this. As we said, we need to rewrite these. So 10 over x cubed is 10x to the power of minus 3. 3 over x squared, that's 3x to the minus 2. 2 root x is the same as 2x to the power of a half. And then we've got the minus 4. And then integrating them one term at a time. Minus 3 will go up to minus 2. And then I'll have to divide by the new power of minus 2. Minus 2 in the second term goes up to minus 1, and I'll have to divide by minus 1. A half will go up to 1.5, 3 over 2, and I'll need to divide by the new power, 3 over 2. And minus 4, that becomes minus 4x when I integrate it, and I get an arbitrary constant. Tidying that up would give me this, and tidying all of that up would give me minus 5 over x squared for the first term, minus 3 over x for the second term. And I combine all of this, I'll get 4/3 x to the 3 over 2 minus 4x plus c. Okay, example 5. They've changed the letter to t, and we're integrating with respect to t, but the method is exactly the same. Again, you'll have to do a little bit of work at the beginning to change all of the terms into the standard form, some number times by t to some power. Okay, pause the video, have a go, come back to me when you're ready. Okay, let's have a look at this. So the first thing to do is just to rewrite all of these in the standard form. That'll be 10t to the minus 4. 3 over root t is 3t to the minus a half. 2t to the 3 over 2, we don't need to do anything with that, or with the minus 4/5. Integrating this first term, the power goes up to minus 3, and I divide by minus 3. Integrating the second term, the power goes up to a half, I divide by a half. Integrating the third term, the power goes up to 5 over 2, and I divide by 5 over 2. And the last term becomes 4 over 5t, and I need to remember the arbitrary constant. Tidying that up will give me minus 10 over 3t cubed plus 6t to the half plus 4 over 5t to the 5 over 2 minus 4 over 5t plus c. Okay, example 6. Now, example 6 needs even more work done to it before the terms are written in the standard form. So all of this is going to have to be tidied up a bit and moved around until you've got terms that all look like some number times by y in this case to the power of some other number. Okay, I'll let you have a go at this, pause the video and come back to me when you're ready. Okay, let's have a look. Well, this expression here, the 3y squared, 3 3s are 9, and y times y is y squared. I've chosen to write the root y as y to the half, and then plus a over the y squared. And then both of these I can divide by y squared individually. So I've still got the 9y squared there on the front, and I'll do a half take away 2, which gives me y to the power of minus 3 over 2. And I've got a over y squared, which is the same thing as ay to the power of minus 2. Now all three terms are written in the standard form. Now I can integrate them. So integrating the first term, the power goes up to 3, and I divide by 3. Minus 3 over 2 goes up to minus a half, and I divide by minus a half. And minus 2 goes up to minus 1, and I divide by minus 1. And I also need the arbitrary constant. Tidying up those terms will give me that. And then I could rewrite the answer just to make it look a little bit more tidy. Y to the minus a half is 2 over root y, and y to the minus 1 gives me a over y. Okay, that is the end of this lesson. If you've got the textbook, turn to pages 172 and 174, and you could have a go at exercises 9A and 9B. Thank you very much for listening, and cheerio.